Okay. Alright, today we are starting lesson 2.4, which means we are starting with congruent figures. So, warm up. What is a word that is used to describe figures that have the same size and shape? There's multiple answers. What can we use that would tell us the same size and shape?
Shape.
Okay, I got equal. No, shape doesn't mean the same size and shape. Okay, so let's see. I have equal. Molly? Equivalent. Same.
Exact.
Exact, not too far off. Okay. The word that we are going to be using that describes all these is obviously what our lesson is talking about, which is congruent.
Never heard that one before.
Now, when we use congruent for our shapes, for one of our transformations, what that means is we are going to make an exact copy that's equal. It's the same. It's equivalent. That the size is going to be the same. The shape is going to be the same. The difference is just going to be maybe where it's located at. If we look at the examples that they have here, what do all of these objects have in common? We have cookie cutters, templates, stencils, and stamps. Savina?
They all make shapes.
Okay, they all make shapes. Okay. What else? Huh? Okay, they all have a design. They make shapes, they have a design.
They all have points.
They're what? Different sizes,
They all
shapes.
have points.
All have points. What if I use
They're all round.
the rabbit and I laid out a bunch of cookie dough and then I took this rabbit cookie cutter and I just started pressing it down in different spots?
It makes a shape.
What about that shape though? All the shapes are going to be the exact same. Same thing with the stencils or the stamps. These are things that in real life make congruent images. Ones that are exactly the same. Take a few seconds. Go ahead, turn, chit chat with your neighbor. Let's see if we can come up with 4 things that we use in real life that make congruent figures. Can't be cookie cutters, templates, stencils, and stamps. But what would be 4 other examples? Go ahead and talk to your neighbor, and then we'll share them out in just a second.
God, why are you so quiet?
Here, I'll give you
Great.
Pencil. Circle. Shape. Pencil. Circle. Water bottle.
It makes it, but is it what do you use it?
I have 2 good ones.
Tracing paper.
Alright. Let's see what we have. Zachary, what was the first one you just said?
I said tracing.
That's actually a really good example. We're using that. So the first thing Zachary said was tracing paper. Yeah, we use our tracing paper. We're using those to help you guys with our transformations. We make exact copies of the shapes that we have to manipulate. Sabina?
Hey, reset your fingerprint on your phone.
What do you mean your fingerprint in your phone?
Like with an iPhone, put your thumb on it so you can unlock it and it like.
Yeah,
Okay.
isn't tracers.
So, kind of. Okay, so like a fingerprint scan, a retinal scan, I mean, that's more for scanning it, but is it making a copy of my thumb?
Yeah. It has it in your.
Kind of making the imprint of it?
Yeah, there's a.
Okay. Yes? Okay. Now, how? Give me a little more. How do I use a ruler to make a congruent figure?
You want it to make like shape symmetrical.
Okay, so maybe if I'm using it in the fact that I'm thinking I'm going to draw something, but I use a ruler to have the exact measurements, the straight lines. Okay.
Staples.
How is stapler?
You like staples?
You just have thinking about staplers now. No, how is the stapler going to make something that's congruent?
Because the stapler, they staple.
It's congruent. It makes the same staples.
So you might say the staples are the same. So I like how we're thinking outside the box there. If you think about a stapler, every time I staple, the staples come out and it makes the staples the exact same. Yeah, I was waiting for someone to come up with that. A printer or like a copier. I'm going to skip that one. I want to get into today's. Now, so it says, learning goal. I understand the concept of congruent figures. Exploration. So, guys, this is what I'm talking about. This is we find new settings again if we need to. Okay, everyone should be opened up in their notebook to this page. Alright.
Ow!
So, Troy, have a seat. If you don't like the minute, go sit in the trash can. I don't need us talking about it. This is what I'm telling you about being distracted. Okay. Everyone should be to this page. I'm going to be doing it on OneNote. Okay, it says, for each pair of the figures whose vertices are given below, draw the figures in a coordinate plane. Okay, you have a coordinate plane underneath, so this is kind of easy. We're going to go ahead, and I need you have this coordinate plane underneath. First thing,
I'll get it back, I swear.
first thing I want to see us doing is putting these coordinates on there. So, everyone should be on 2.4, congruent figure exploration. So they tell us, I need you to put a point at -5, 1. Label it A. Then we'll go to -5, -4, and label it B. Then we'll go to -2, -4, and label it C. Connect the dots, and then we're going to draw our second shape. Go ahead and do this quickly. Right here, buddy. And then -5, 1. Yeah. Yeah.
Are the E, E, and F a separate, different shape?
Yep.
Okay. Just need to make sure. What paper is this? Are you not going to grab it?
Here.
one, second one too.
Yep. Well, the two triangles. Okay, you should. 1, 4, 1. Oops. I messed this up. -2.
Yeah, but that one says your name. That one. Oh my god.
Okay. So now that you should have these two triangles drawn, the big question is,
But because the y on the black one, it's every y component is negative.
huh?
Like point A is supposed to be negative 5, 1, but you went negative 5.
Left 5, up 1.
I get it right. It's like,
Alright, so let's focus on this. Oh my god, you're very straight. Okay, if I look at my two triangles, the big question that we are asking is, are the two congruent? Now, me, honestly, when I look at them, I know what the answer is, and the answer is yes. But I look at them and I say, no, the orange one looks a lot smaller than the other one, correct?
Yes. No. No.
It definitely looks like it's smaller.
No.
But there's a couple of ways. What do you mean?
I just think those two triangles. I don't know what happened. But I just think those two.
I didn't get that
It's
either.
-5, 1.
Yeah, I can't get
So that should be A. -5, -4. So like A, B, -2, -4. Connect. And then you should have 1, 4. Just count B. 1, -1. 1 over up. So, here's what we need to do. We need to prove that these two triangles are congruent. So, the first thing I'm going to do is I'm going to make sure everyone has some tracing paper again.
Ow!
What you do?
Okay, this is going to be what. This is going to be what I will do a sucker reward over.
Oh, yeah.
Can you prove to me mathematically that these two triangles, why is this not drawn yet?
are the same.
So I need to mark you and then give you a pencil. So you didn't come prepared to do this.
Well, actually, I got to take homework covered, and I got kicked out, and everybody she has my track.
No. Okay, so now you only let you catch it. So you have a track or
I already have a
something.
teacher on Monday.
You have one on Tuesday as well. Okay. You were choosing to mess
Can
around
I get my
instead.
tracker from you?
It's already due.
I
I'm
want
done.
you to mess
Zach,
around.
I'm in math and I'm moving on. Okay, here's your goal. I need you to figure out how can you prove this to me. How can you prove to me that the two triangles are congruent? You have to prove it to me mathematically. So, work on this, focus on this. I'll come in just a little bit to help, but I want to see, can you figure it out and can you teach it to one other person?
Figure the second one out.
Oh. What did I put?
Ah.
You wrote this one.
How do you prove it?
Well, not scientifically. So basically, you put the triangle on a triangle, and you turn the triangle around, and move the triangle up, and boom.
You're getting really, really close, but that doesn't sound mathematical.
That's
Everything you said is right, but how do you explain it mathematically So what you say, every math person understands will do the same thing.
You turn it around and
What's
then
it
Add
mean?
math facts. Like, you know, their terms.
He's not that. He's not gonna.
5 times 3 is 8. That's a fact.
A little bit.
5 plus 3, not times. Never mind. It's 40.
Avery, did you hear what he said?
No, I'm sorry.
He
I'll
goes,
no,
he goes
no,
5
no,
times
that's
3 is
not
8.
15.
I meant to say plus, don't believe me.
Good. So we're getting closer.
I
Mathematically,
meant
you're
to
a
say
lot
plus.
closer. Okay, so let me give a little hint. I've heard some people saying that are getting closer. Oh, I heard a couple people get closer and they said you have to flip along the y-axis. Well, you just said we have to flip it. And then I heard we have to turn it, or we have to move it. Those are not our mathematical terms. We're talking about transformations. We should use translate, reflect, and rotate. Those are the 3 that we've learned so far.
You reflect it and then move it up.
Okay, I disagree. If I reflect it and move it up, I don't think I'll get the same shape.
Yeah, you're probably right.
Because I might reflect it a different way.
Reflect
You
and rotate.
reflect it along the y-axis.
Okay, hold on, let's start there. What?
Reflect it along the y-axis.
Alright, do you have yours copied in your notebook? Alright, bring it up here.
He's always paying attention.
Put it underneath the overhead. Alright, so let's work on this. Let's look at this. Okay, put your transparency paper down.
Guys, I'm not gonna do that.
Okay, so if you're telling me to reflect along the y-axis, okay, so I could do that, but what I would need us to do, I'm going to jump in real fast. You would want to mark on your transparency paper where my axes are. Alright, so now that we have that, go ahead and reflect on your y-axis. What would we get? We still line up our points. Okay. There, he has just reflected on the y-axis. Now what would you do, Troy?
And then you would move it over.
Oh, but what's move it over?
You would
Translate.
Translate.
Translate. Okay, so hold on. Let me write this down. You're saying reflect on y-axis. Okay, so we reflected on y-axis, and now you want me to translate which direction?
To the left.
Okay, so translate left. How many units am I going to go left?
3.
Yeah, 3.
Okay, so go ahead and slide it left 3. Okay, let's come to here.
Yeah, you were right.
Translate 3 left. And we're not there yet.
And then translate
Go down.
3 down.
3 down. Okay, slide it down. Now, do my 2 triangles match up? Okay, so I'm going to say reflect on y-axis, translate 3 left, 3 down. Alright, good job, Troy. You can take this up. I'll throw you a sucker in just a second. Now, pay attention to this. This is correct. Is this the only way to get to that point?
No.
No. To be honest, one of the ways that they were having to show you was if I did the reflection right here. If I would have reflected, Sierra, focus here please. If I would have reflected at x equals -2, that would have flipped this triangle right here over there, and then I just translate 3 up. Let me show you that. So, Troy, actually, I'm going to use your paper. Put it underneath one more time. And move. Okay. If you're focusing right up here, you're going to see another way we could have done it. If I would have translated here at -2, x equals -2, I would have got my triangle like this. Then I could have translated up 1, 2, 3. 1, 2, 3. So this is why you're going to be wanting to pay attention to this, because some of you are going to get some points off because we are going to ask you. Oh, whoops. We'll ask you to translate this or transform the shape in the least amount of steps. Girls, please focus. So, if we ask you to do something in the least amount of steps, we need to look for that. Or this one would have been to reflect at x equals -2, translate 3 up. This way works. Okay? So, here's what we're going to look at now. You have a second one. We're going to do the same thing. You need to graph these 3 points, label them, graph these 3 points, and then I need you to prove to me through transformations that the 2 shapes are congruent. Okay? I'm going to pause our video in just a second, but I want you to work. Alright, here's our answer. Now, a few of you, when I'm coming around, you guys were getting that they are congruent. You use your tracing paper. And the biggest thing that you said, though, was I need to rotate it. You figured out we are turning. Rotate 180 degrees. And to be honest, I don't have to say clockwise or counterclockwise. Why? Because why? Why did it matter if I went clockwise or counterclockwise?
No!
It's the same.
Either way, you still want to do
Yeah, if I rotate, so here you go, Ben. If Ben Sucker's here, and I rotate 180 degrees right, it'd be upside down. If I went 180 degrees the other way, it'd still end up.
Okay.
Because up here on the board, I drew this up here. Our circle's 360. If I go right 90 degrees, I'd be at the same place if I went left 270. Because 270 plus 90 is 360.
It's like married
180
numbers.
to 180, it's like what?
Married numbers.
Oh, I thought you said married people. It's like,
Oh, married numbers. You know how like 7 and 3 they
Yeah.
make 10, and then 5 and 5 make 10, and then like 4 and 6 make 10.
Yeah, exactly.
Like every
So,
first
right here, I didn't have to say clockwise or counterclockwise. However, if it's anything besides 180, then I'd have to say clockwise or counterclockwise. However, focus, we're almost done. There's one thing that Molly caught that no one else had put yet. She said that we had to rotate 180 degrees around the origin. You have to tell us, where is my rotating point? So, what that means, I'm going to steal Miles' real fast. Girls. When I steal Miles' paper real fast, and I take this right here. I did this to Ryan. When he told me rotate 180 degrees, I put my pen here, and I rotated my paper 180 degrees. Well, the triangles didn't line up. It didn't match up. So that's why we have to make sure we know where we're rotating from. If I put it here at the origin, and I rotate, that is when my figures would match up. Okay, one last question. You need to take your notebooks, turn the page, there's one last one. So, do this one, and if you can prove it to me mathematically, you win.
You win.
You win. You win the sucker. So there's one last one. Alright, so a couple of you already were saying part of this. We were so close. Molly actually got it by saying specifically, mathematically, they are not congruent. So you are right. You're getting into something. They look almost exactly the same. The shape's the same. Everything is falling in the same spot. If I shrink it. This is going to lead into, in a couple days, where we talk, these shapes might be similar, which means everything is proportionate. We just have to make it bigger or smaller. We'll talk about that when we do dilations. But for right now, we were asking, are the two shapes congruent? The two shapes not congruent. Okay. Now, which pair of figures are identical? We already did that part. So, I know we kind of did it as we went instead of the questions. The ones that were identical were our two triangles here. Those were the only two that were congruent because we were able to do transformations to match them up. We are going to hit this part up on Monday. This is the second day of your homework. Hope you guys can do this. It's not much. Homework, you still have 4 minutes, which means you would probably get through the majority of this. Oops, wrong one. Okay. Let me finish this and then you guys can have your time. On number 6 and 7, determine whether the figures are identical, which is meaning are they congruent. So they're going to give you points. You have to tell me, are they congruent? Which means, did we do a transformation, translation, a rotation, a reflection? On 8 and 9, identify them. So tell me if they're congruent, which ones, and tell me how did we get to it. I want to see this, exactly what we did here. So if you say the two shapes are congruent, say I reflected on the y-axis, I translated left 3 and down 3. And then the last two, so that's only 2, 4, 6 questions. The last two, tell me how they were transformed. Remember, if it's not congruent, you simply say not congruent.